All right, so we just finished making this map of the entire world, and now we're going to apply some of those same skills, but tweak it a little bit just to make a map of the United States. So right now it looks like absolutely nothing, but we're going to be reusing a lot of the same code. So if we look at our index file, it's pretty much the same as it was last time. We have D3 included, we have topojson library included. Just a quick review, topojson is a format that is wonderfully small that you can use to pass around geographic data. So when you're serving maps on the web, which is the time where you don't want to send people megabytes and megabytes and megabytes of information, using topojson is really good because you can get a really detailed map but not have it be a huge file. So then we are also including visualization.js, which is our JavaScript here. So what we have done is we have our standard method of starting off a D3 visualization. This is kind of our boilerplate where we select a div on the page, we put an SVG on the inside, we put a G inside of that, we've transformed and translated. But in this case, for all maps, it really doesn't matter if you do transform and translate because it isn't going to affect anything. So what we should probably do is I've just set all of my margins to be 0. We could get rid of all of the margin stuff, but it's comforting to me to just use the same boilerplate every single time we make a visualization. Then we read in our data. The data this time is a file called us.json. And you say, Soma, last time we had world.topojson. This is just us.json. Is this some sort of different file? The answer is no. Generally, when you get a topojson file, the file format, or the file extension rather, is just going to be .json. It's not going to be topojson. Sometimes it is. Sometimes people name geojson.geojson, topojson.topojson, but probably the majority of the time it'll just be .json. Let's see, what else do we have? I stole this projection from the last visual we made. This one is based on the whole world, so we're going to end up changing it. Let's see, it's a projection is the way that you translate the latitude and longitude of a globe. So a globe is a sphere, and oddly enough, our computer screens are not spheres. Our computer screens are flat. So you need some way to kind of cut apart and stretch apart that globe to make it fit onto your screen. And that's what a projection does for you. And then down here, there's a little piece that will take that projection and help convert it into a something that can take a series of latitude and longitudes and draw a shape for you. So this is the way that we ended up setting the D attribute of the paths last time. And if you're like, what are you talking about? Go back and watch the last video, or just watch this video, because literally every time you make a map, you are going to use this exact same code, and a lot of the time you'll use code that looks pretty much like this. So you're not missing much except me saying and a long time for the other video. So all right, first thing we're going to do, we are going to console.log data, because you should always see what data is coming in. This is your data here, which is directly related to your us.json. So us.json gets read in, then it gets turned into this data. So save, refresh. Oh no, why isn't it showing up? What did I do wrong? That file is there. Okay, had to force refresh. Had to hold down shift so it would acknowledge my change. So all right, we have an object that has arcs, has objects, that has transform, and has a type. Every single time, talked about this last time, every single time you pull in topojson, the thing that is important to you is what is inside of objects here. We're going to open it up. We have counties, we have land, and we have states. So let's start off by drawing states, and then maybe we can go in and draw some counties later. So last time we drew a visualization. Let's look at our other visualization.js. We did this here. We did var countries equals topojson.feature data data.objects.countries.features. Yes, it's stupid that there's feature here and features there, and there's data here and data objects here. that every time you do topojson, you're going to be doing this same thing. So here's what we're going to do. We are pulling out the states. So var states equals topojson dot feature, and then you need to send it the root of all of your data, which is data, and then what specific piece of the topojson we would like to process. So as I said before, it is an objects states is what we're after. So we're going to do data.objects.states, and we're going to say give me the features. So if we console.log states, save, refresh, we end up with a big long list of a bunch of different states. They don't have names. That's so sad. Why do they not have names? Well, I guess that's a shortcoming of our data. Such is life, I guess. All right, so let's draw those states. So whenever you draw shapes on an SVG, you're going to be drawing paths. Paths are lines that are complicated lines, and if you fill them in, they become shapes. So we are going to svg.selectAll, and we'll call these states. And we're going to bind the states data to it, enter, append. We're going to add a path, one path for every single state, and we're going to make sure it has the class of state. Now, if we save and we refresh, we're going to see that nothing has shown up on the page. We have an SVG here, and there are a bunch of paths inside, but the path needs a D in order to actually have a definition. I don't know what it is. In order to have a series of points that it follows along in order to get drawn. So every single time you are drawing a shape and you have a projection and you have a geopath generator here, attr_d path. That's all you got to do. We're going to save it. We're going to refresh. Look at that. It's beautiful. Except it's not beautiful because it's way up on the top left-hand corner. Now, what we could do is play around with our projection. So if we played around with what it was pointing at, let's say we zoomed in a little bit, and we had centered it around the US, we could do that, sure. But generally speaking, the United States is so wonderful that it has a special projection in D3 that will just center itself around the United States. So geo.AlbersUsa, all caps USA. And we are going to, so now instead of being about the entire world, it is just about the United States. And no, it is lowercase sa. Let me change this one too. All right, so we look at this, and sure enough, it is not only just the United States, but it has also taken Alaska and Hawaii and popped them down in the bottom corner. So now what we need to do is we're going to need to change the scale in order to zoom in on this. So our scale is 100. If we made it 500, it'll be a bit bigger, but not quite big enough for us. Maybe we'll go up to 850, and it will probably look a bit better. How do you pick the right number? You just make up things. You just go in and out. One thing you could do is make sure the aspect ratio of your background SVG is correct. So you can see now we have a little bit of space on the left hand and the right hand side. So we could make it fit right inside of our SVG, but we don't care enough about that right now. So in order to pull this into a graphic that is just about the United States, all we had to do was import a different set of data and then change our projection to be GeoAlbersUsa. The one downside about GeoAlbersUsa is if you try to feed it any information that is not in the United States, it will freak out, it will break, it won't just, let's say normally when you have dots and you're trying to put a bunch of circles on a map, if you do something wrong, they'll end up in the top left-hand corner at 0, 0 because they'll have not a number as their coordinates. If you try to feed latitude and longitude to the GeoAlbersUsa projection, and let's say it's Puerto Rico, which sometimes comes in with Census Atlas or with census data, it will stop working and it won't freeze your computer. It will not process anything and you won't be able to see anything on your visualization, which will be very sad. So if you were getting a very strange error when you are trying to map stuff that is just in the USA, you might have some data points that are not actually inside of the USA. So let's change, let's use some CSS in order to change what this map looks like. Let's see, it is with the class of state. So let's go into our index and we'll say dot state. Let's say fill. Let's make it even lighter. E3 seems to be a nice one. And there you go, but when you want to see the lines between it, so let's say stroke 333 and make it nice and thin. And there we go, we have the United States. Well, yes, we do have the United States, but we also have some more information that's hiding inside of our topojson. So a great thing about topojson is instead of just having one file as one data set, you can have a ton of extra information in there. So for example, if we open up objects here, this is our topojson because we console.logged it a long time ago, and we have counties, and we have land, and we have states. So let's look, let's take counties, let's graph the counties. It's going to be the same thing that we did here, except instead of extracting the states and mapping the states, we're going to extract the counties and map the counties. So if we look, it's objects, counties. So back to our visualization.js, we are going to say var counties equals topojson.feature data data.objects and again objects.counties. Every time you pull in a different topojson file, you're going to want to console.log it to see what your different options are. .counties.features. And now we can honestly just cut and paste this code here and change state to county, state to county, and we will bind counties to it. So now we are adding all of these states and then we are adding all of these counties. So I'm going to save, I'm going to refresh, and there you go. Right on top of everything, we now have all of the counties in the United States. So what I'm going to want to do is let's make these maybe transparent, and then we will give them a stroke that is white. So there will be problems with this later on, but you'll see. So if we look here, the class is county, so I'll say .county, fill none, stroke FFF, and we'll make it also pretty thin. Okay, so we now see that we have a ton of counties on here, but the issue is that the county lines are interfering with the state lines. So let's say if we made these state lines kind of thick, 2.5, we will see the county lines are running on top of and through the state lines. And this becomes an issue with draw order about what layers are on top of what other layers. D3 actually has a way for you to raise and lower specific layers, but what we are going to do instead, the problem we're having right now is you have state layers that have a gray in the background on the bottom, and then you have transparent counties on top that have a white line. And that white line is getting in the way of the black line of the states. So we're going to switch this up. We're going to put the counties on the bottom. We're going to give them the gray. And then we're going to put the black lined states on top. So first, let's switch this around. So we'll draw the counties before we draw the states. You're going to be so surprised when I refresh this. You're going to say, oh, the counties have all disappeared. The counties disappeared because these states have a fill color, and that fill color doesn't let you see the counties underneath. So what we're going to do is we're going to get rid of the fill color for the states, we're going to give it no fill color, and we are going to instead give the counties on the bottom that fill color. Save it. And there you go. I mean, this looks tragic because our stroke is real thick. But yes, now you have a map of all of the states and then all of the counties inside of it, and they look rather splendid. And just to top this all off, let's go ahead and add a CSV into this. It's the exact same stuff we did last time with the world map, but we're going to do it again. So my favorite data set in the world is this data set with a ton of different Waffle Houses in America. So they each have a latitude and longitude and a score and a location. Oh, this is the score. I made that score up. Sorry. I think it's how close they are to Atlanta. So we now need to, along with reading in us.json, we're going to read in a CSV file called wafflehouses.csv. So when we add a new thing to defer, we get a new data set here. So we're going to call this Waffle Houses. We're going to go down to the bottom, and we're going to console.log Waffle Houses, just to make sure the data came in okay before we try to draw it. So save, refresh, scroll down. Does this look like a bunch of Waffle Houses? Yes, it does. Latitude, longitude, location, score, beautiful. So we are going to plot these on the map, which means we need to convert all of those latitude and longitudes into X and Y coordinates. So first off, let's do svg.selectAll, and we're going to call this, each one of these is going to be a Waffle House. We're going to bind our data and add a circle for each one of these. Now, in order to, this is .wafflehouse here, so we're going to do attr class Waffle House, and we're just going to give them a radius of, let's say 2. That should be fine. We now need to set the CX and CY though. Let's set them each just to 10 right now. Save it, and then there will be a ton of circles that are right there that are so on top of each other they become a square. So what we need to do is we need to take the latitude and longitude, convert it to an X and Y so that it will show up on this page. And the way that we do that is we use our projection. So if we console.log d, this is each one of our Waffle Houses. There's a column called lat, and there's a column called long. And we just feed that to the projection, and the projection turns it into an X and a Y. So var coords equals projection, d.long, d.lat. And let's just look at the coordinates that we get back from that. So there we go. We have an X and we have a Y. So right now we are just trying to get the X value. So we are going to return coords 0. Now it's kind of weird that you need both the latitude and the longitude in order to just get the X, but that's how projections work. So every single time you are mapping something with latitude and longitude and putting it onto a map as a dot, you are going to use this. You are also going to use this. We're going to set the CY, and we're going to return not the first coordinate, but rather the second coordinate. So the first one is the X, the second one is the Y. We'll save it. We'll refresh. And hey, look at that. We got a lot of Waffle Houses. Maybe we throw a little opacity on there so we can see through them. Maybe a little less opaque. And then you can see, wonderfully enough, where Waffle Houses are focused around America. So yes, we changed our projection to being America. We use several different layers inside of our topojson in order to draw both states and the counties underneath. we adjusted the draw order between the two and the CSS so that we would be able to see state lines without having them be interfered by county lines. And then we added some dots on top of that. So not too bad at all. The next video, we are going to look at these shapes here, which is just a bunch of clusters. And instead of having it be oddly distributed around, we are going to break these into different segments and then count the number of Waffle Houses in each one of those bins. And if you say, what? Just look at the next video in the series and know what I'm talking about.